I'm back. Let's pick up where we left off. Okay, so we're doing cyclic quadrilaterals. Just a quick recap. So cyclic quad. Okay, so a cyclic quad is a shape where all four corners touch the circumference. Shape where all four corners touch the circumference. So literally a four-sided shape. So you could have your circle and then you have something like a square. But then all corners have to be on top of your circumference or circle. And then we said we have how many theorems under this one? We only have two, so two theorems relating to a cyclic quad. The first one is that opposite angles of a cyclic quad are supplementary. So opposite angles of a cyclic quad add up to 180. Remember, angles that add up to 180, we call them supplementary angles. Okay, so what do we mean by that? We mean in our shape above, if I say angle A plus angle D, I will get 180 because they told me that this is a cyclic quad. Or if I say angle B plus angle C, I'll get 180. This is only if when you look at your circle or when you look at your shape, you can see the four-sided shape and the four corners are at the circumference, or they already told you that it's a cyclic quad. If there is no shape, or if your shape is not inside a circle, or they didn't say anything about it being a cyclic quad, then you can't assume that it's a cyclic quad. So another theorem, so this would be theorem 1, that would be 2. The second theorem is that the exterior angle of a cyclic quad, is equal to the opposite interior angle. Okay, so here is your shape. Okay, this is A, B, C, D. So this angle is equal to that. And if I was this side, if I was the other side, then it would be this one equal to that. Okay, so angle A would be equal to angle, let me write P here, here I'll write K, so it will be equal to angle BPU PBDP. Okay, and angle B would be equal to angle ACK. And then your reason would be exterior angle of a cyclic quad. Okay, for this one, you just say op angles of cyclic are supplementary. Okay, and then a question can come saying that prove that a shape is a cyclic quad. So how would you prove it? So proving a cyclic quad. Okay, so to prove that a shape is a cyclic quad, you can find the opposite angles using other methods. Find opposite This is opposite now. I know, guys, my handwriting is very nice, which is why you need to pay attention to what I'm saying so that, yeah, you see it clearly. But anyways, find opposite angles using other mathematical ways. Mathematical ways. Then, if you add them, or let's use proper English, if the sum is, if their sum, if their sum is 180, then you have a cyclic quad. Okay, we'll do a few examples under this. And then number 2, if another way you can prove that something is a cyclic quad, you can find the opposite angles. So you're going to find the opposite in angles inside, I think, yes, opposite angle inside your shape. Then find also your exterior angle. And if they are equal, then we have a cyclic quad. Okay, another way to prove that something is a cyclic quad, you can prove angles in the same segment. So angles in the same segment. Okay, so also you're going to find the value of your angles using other ways. And if your angles are equal, then we have angles in the same segment, then you have a cyclic quad. Remember, angles in the same segment, you'll have a circle, and then we see it with a bow tie. So if I have a bow tie like this angle will be equal to this one, and this one is equal to that one. So using other mathematical ways, you saw that these two angles are equal. Then it means you will have a cyclic quad. Why? Because angles in the same segment, if we join here, can you see we're going to have a four-sided shape where all the four corners touch the circumference. So i.e., if A equal to B because of angles in the same segment, or C equal to D. This was supposed to be D, but it is D. Or C equals to D, then we have a cyclic quad. Okay. I just want to finish the tangent theorems, then we can go to questions. Okay. So now we go to tangent. So what's a definition of a tangent? A tangent is a line that will touch your circle once, or any shape once. A line that touches our circle only once. Okay, so if we have to draw a picture to explain this, so we have that. Ooh, I'm dumping the gun. So yes, so this would be our circle, and then this would be the tangent, and then these two, they touch only at So theorems under tangent are: a tangent is always perpendicular to the radius or the diameter. So tangent is always perpendicular to a radius. So remember, a radius is half of a what? A diameter. So this means that also a tangent would be perpendicular to a diameter. So in this case, if they tell you that this line, and here is the center, and then we have that, this, okay, oh my word, oh my word, oh my word, okay, you have a circle, and then we have a tangent, and then they'll tell you that this is a center, and then that's a radius, so this is O, okay, then we are allowed to say OK is perpendicular to what? KP, meaning that angle is what? 90. I'm going to write it in a different color. So that's 90. And then the reason that you use, so your reason is just tan perpendicular to right, or right perpendicular to 10, whatever one you want to use, doesn't matter. Okay, the second theorem under tangent is tan chord. I love this theorem. I don't know why I love it, but I do. So for tan chord, you're going to have a circle, and then inside the circle, you're going to have a triangle. Please note that this triangle, all the three corners have to touch the circumference. You can't have a triangle that floats in the air, like something like this. Then we can apply tan chord here. The correct one is this one. So can apply tan chord there. But okay, this one, your triangle, all the three corners have to touch the circumference. And then let's say you have a tangent here. So what tan chord says is that the angle between a tangent and a chord. So here is my tangent. Maybe I'm looking at it from this side. And then where's my chord? My chord is green. The chord CB. So the angle between a tangent and a chord, which would be this one that I'm shading in black, is equal to the angle that is opposite that chord. So here's my tangent and the chord. And then if I'm here, which angle will be opposite my chord? The angle A. So meaning angle A is equal to angle BCK. So if I was going to be the other side, I'm going to name it the same way again. So I have A, B, C. But instead of us going the other side, I want to be this side now. So here is my tangent. Oh, I forgot to put it as a highlighter. Here is your tangent, and then where's your chord? And then there's the chord. So remember what tan chord says: the angle between a tangent and a chord. So there would be my angle between a tangent and a chord is equal to the angle opposite that chord. So if I'm at this chord, which angle will be opposite the chord? Angle B. So angle, so let me put P here. May not use, so P. Angle ACP is equal to angle B. Whenever you use this theorem, your reason would always be what? Tan chord. So reason to use, you just write tan chord. Maybe that's why I like it, because it has a short reason. But what the theorem says, so theorem say angle between a tangent and a chord is equal to the angle opposite that chord. Yep, that's chord theorem. And then the third theorem under tangent is that tangents from the same point are equal in length. So I have my circle, and then I have a point outside. Then, as long as they start at the same point, which is K, and then we will put K, P, K, C. So as long as they start at P, both of them start P, so tangents from the same point are equal in length. Okay, so i.e. both PK and PC starts at what? At P, and they're both tangent. So this means that they are equal. Okay, so on the next two videos, not two, okay, on the next videos we'll be doing examples. It can't be two because I don't know how long. Okay, bye.